Last time we began to look at the argument for design based upon the fine-tuning of the universe for intelligent life. And we saw that over the last half century or so, scientists have been stunned by the discovery that for intelligent life to evolve and exist on any planet, anywhere in the universe, the initial conditions of the Big Bang have to be fine-tuned with a complexity and delicacy that literally defy human comprehension. In order for the universe to be life-permitting as it is, the values of the fundamental constants and quantities of the universe must fall into an extraordinarily narrow range of life-permitting values, such that if those values were to be strengthened or weakened by less than a hair's breadth, the balance would be upset and life of any sort would not exist anywhere in the universe. Now, sometimes people will object to the fine-tuning by saying, well, maybe in a universe that is governed by different laws of nature, these disastrous consequences would not result from an alteration of the values of the constants and quantities. But this objection betrays a misunderstanding of the argument. We're not concerned with universes which operate according to different laws of nature. We have no idea what would happen in universes that are operating according to different laws of nature. Rather, this argument is concerned only with universes that are operating according to the same laws of nature as our universe, but with different values of the constants and quantities. Because the laws of nature are preserved and merely the values of the constants and quantities are altered, we can predict what would happen if these values were increased or decreased marginally. And so our concern is with universes governed by the same laws of nature, but with different values of the constants and quantities. The Canadian philosopher John Leslie gives a very engaging illustration of this point. He asks us to imagine a solitary fly resting on a large blank place on the wall. A single shot is fired, and the bullet pierces the fly. Now, even if outside of the large blank area, the wall was covered with flies, so that a randomly fired bullet would probably strike one, nevertheless, it remains the case within the large blank area, it is highly improbable that a randomly fired shot would strike the solitary fly. In all probability, the randomly fired bullet would hit some other portion of the large blank area. Now, that solitary fly is just like our universe. And the large blank area will be other universes governed by the same laws of nature, but having different values of the constants and quantities. So we're not concerned what would happen outside the blank area. Universes that have different laws of nature, nobody knows what would happen in those. Rather, the question is, in universes governed by the present laws of nature, but having different values of the constants and quantities, how probable is it that the universe should be life-permitting? And the answer is that a life-permitting universe is like that solitary fly in the large blank area, except incomprehensibly more isolated than John Leslie's fly on the wall. Because the laws are the same, we can determine what would happen when you alter the constants and quantities. And as I said last week, the results turn out to be simply disastrous. A life-permitting universe is incomprehensibly improbable. Now, is there any question about that point before we move on to state the argument from fine-tuning?
Would one respond to that in that life I hate to use the word evolved, but life became real in this universe, then of course it would be in those, because of that's the origin of the life, then of course such a fine-tuning would be obvious or present.
It would be present. It's not just obvious. Scientists haven't discovered this until the last several decades, that these initial conditions were fine-tuned like this. But yes, you're absolutely right. Do you see the point that Cindy is making, and I'll reiterate this later on, is that for life to evolve anywhere in the universe, the initial conditions in the Big Bang have to be there to start with. Otherwise, life would never evolve anywhere. So that the question of evolution just becomes irrelevant to this version of the argument, because these are initial conditions, and therefore they are not the product of prior evolutionary processes. This is the way the universe starts out. All right, any other comment?
So would the fine-tuning really deal more with a metaphysical nature than it was a physical one, seeing as it's dealing with the initial conditions?
It is physical. We're talking here about physical parameters that are not discussed in philosophy. This is physics. It is an example of what one cosmologist has called metaphysical cosmology. Modern cosmology has become almost metaphysical in its implications and ramifications, and this would be one example of that. But these are parameters that are discovered by astrophysicists, people who study the universe.
Gotcha.
Yeah, so this is very much a physical concern or scientific concern. Yes, Eric.
I was doing some research on this for a presentation a little while ago myself, and I ran across an objection, I believe, that was brought up by Victor Stenger, when he claimed that the universe, the fine-tuning isn't as extreme as we might think, because basically the different constants sort of balance each other out, that a fine-tuning, a large variance in one can be balanced out by another, so the fine-tuning isn't really as extreme as what it might appear to be.
Yeah, Stenger, who is, or was, he's passed away now, was an ardent naturalist and atheist, was very bent on getting rid of this fine-tuning argument, and took positions that I think are defended by very few. Robin Collins, in particular, has responded to Stenger's objections in his work, for example, in the article in the Blackwell Companion for Natural Theology. And what Robin points out is that these parameters are distinguished by their independence from each other. There's no reason that adjusting, say, the proton to neutron mass ratio would have an effect upon the low entropy of the early universe, or that somehow these are connected. As I said the other day, it's not just the number of these constants and quantities that need to be fine-tuned, but also their variety and their independence from each other. But actually, the point that Stenger makes, I think, really reinforces the improbability of the fine-tuning, because you have to consider not just these things in isolation, but their ratios to one another. And if they really are interconnected in the way he imagines, that would be even more remarkable, I think, that you would have this sort of, these sort of interconnected ratios that would be necessary for the universe to be life-permitting. So take a look, if you're interested, at Robin Collins' responses to Stenger. All right, well, the question then that we face is, what's the best explanation of this remarkable fine-tuning? Fine-tuning is a fairly uncontroversial fact of nature when understood properly in a neutral sense. And many people today are coming to the conclusion that the reason the universe is fine-tuned for intelligent life is because it was designed to be that way. It was designed to be life-permitting by an intelligent cosmic designer. But design is not the only alternative. There's also physical necessity and chance. And so the key to inferring design as the best explanation will be eliminating these other two alternatives. So in accord with this, we can present a very simple three-step argument that's easy to memorize and to share with another person. And it would go like this, and this is on your handout. 1, the fine-tuning of the universe is due to either physical necessity, chance, or design. Premise 2, it is not due to physical necessity or chance, from which it follows, therefore, number 3, it is due to design. So this is a very simple formulation of the fine-tuning argument. And notice that by focusing on the fine-tuning, this argument does an effective end run around the emotionally charged issue of biological evolution. The argument from fine-tuning, as I said a moment ago, if it's successful, will show that the evolution of intelligent life anywhere in the universe depends upon the design of the initial conditions of the universe. Any design arguments that you want to float from biology, for example, from the origin of life, or the development of biological complexity, the origin of consciousness, and so on and so forth, will simply layer on more improbability on top of the fine-tuning, making it all the more unlikely that this can be explained apart from a designer. So this argument doesn't rely upon instances of biological design or anti-evolutionary arguments. Those sorts of arguments will simply strengthen the case for design by making life even more improbable than it already is based upon the fine-tuning. Now, the first premise of the argument, that the fine-tuning is due to either physical necessity, chance, or design, is unobjectionable because it just lists the alternatives that are available for explaining the fine-tuning. These are the alternatives that are discussed in the literature today. If somebody comes up with a fourth alternative, then he's welcome to add it to the list, and then we'd have to consider it when we come to premise 2, but there doesn't seem to be another alternative. These are the 3 principal alternatives that are discussed in the literature. So the real question then is premise 2. Is this premise more plausibly true than false? If it is, then it will follow that the fine-tuning of the universe is due to design. So let's say something about the first alternative, physical necessity. According to this alternative, the universe had to be life-permitting. The constants and the quantities must have the values that they do, so that a life-prohibiting universe is literally physically impossible. Now, on the face of it, this alternative seems fantastically implausible. It would require us to believe that a life-prohibiting universe is a physical impossibility. But why take such a radical view? As we've seen, the constants and the quantities are not determined by the laws of nature. The laws of nature are consistent with a wide range of values of these constants and quantities. So there's nothing in the laws of nature that would make these constants and quantities necessary in their values. So why couldn't they have been different? The arbitrary quantities, remember, are just initial conditions on which the universe or the laws of nature operate, and nothing in physics is known that would suggest that there are laws of initial conditions that would make these physically necessary. So the opponent of design is taking a very radical line here that would require some sort of proof. But there is none. There is no proof, no evidence that the values of these constants and quantities are physically necessary. So this alternative is simply being put forward as a bare possibility for which there is no evidence, and therefore doesn't commend itself to us. Now, sometimes scientists do talk about a yet-to-be-discovered theory of everything, or a TOE. a so-called theory of everything. But like so many of the colorful names which are given to scientific theories, this label is very misleading. A successful TOE would not, in fact, explain everything. The goal of a theory of everything is to provide a unified theory of physics which would unite the four fundamental forces of nature: gravitation, electromagnetism, the strong force, and the weak force, into a single force which is carried by a single particle. But it wouldn't even attempt to literally explain everything. For example, the most promising candidate for a so-called theory of everything today is M theory, or superstring theory. But superstring theory only works if there are 11 dimensions, not 4 dimensions, such as we observe. It only works in an 11-dimensional universe. But the theory itself doesn't explain why there would exist exactly 11 dimensions rather than any other number of dimensions. That's just presupposed by the theory. Moreover, M theory does not, in fact, uniquely predict the values of the constants and quantities that we observe in our universe. M theory, in fact, permits a wide range of universes having around 10 to the 500th power members with different values of the fundamental constants of nature. These universes are all consistent with the laws of nature, but they have different values of the fundamental constants of nature. And almost all of these universes turn out to be life-prohibiting rather than life-permitting. This is sometimes referred to as the cosmic landscape of worlds that are consistent with M theory. And this cosmic landscape has itself become something of a phenom in popular science articles lately. But it's important to understand that this cosmic landscape is not real. It's just a range of possibilities. Some people have misinterpreted the cosmic landscape to mean that all of these different universes actually exist, that they're really out there. And some people have thought that it therefore undermines the argument for design, because if all of these different possibilities exist, then there have to be life-permitting universes like ours. But the cosmic landscape is not real. It's just a list of possibilities. It just describes the range of universes which are consistent with M theory. And that range is so incomprehensibly large, 10 to the 500th power, different possibilities, that some explanation is needed for why a life-permitting universe exists rather than a life-prohibiting universe. Since life-permitting universes represent a virtually infinitesimal proportion of the cosmic landscape. So, you can't say that life-permitting universes are physically necessary on account of this theory of everything, or M theory, because, quite frankly, that's simply false. It is not true that M theory predicts uniquely our universe. So, there's no evidence that a life-permitting universe is physically necessary. On the contrary, in fact, not only does science suggest that such life-prohibiting universes are possible, but that they are, in fact, far, far more likely than any life-permitting universe like ours. Now, is there any question about that first alternative, physical necessity? Yes, Elizabeth, we'll get you the microphone so that we can hear your question.
Thanks. Yeah, I just had a question. I wonder if someone could respond like this. At the beginning, you restrict the scope of possible worlds that you're looking at to like the nomenologically possible worlds, the ones with our laws of nature. And so I wonder if someone could say, oh, well, if you're going to restrict it in that way, why can't I just restrict it to the ones with R constants? I mean, you're making a restriction anyway. They both might seem a little ad hoc, but I don't know, kind of turn it back on you like that. So I'm just wondering what you would say
in
to
a
that.
sense, that is what the person who's defending physical necessity does, is he's saying that the values of the constants and quantities we observe have to be that way, so we're just going to restrict our attention to those. But then there isn't, as I say, any reason to think that, and all of what we know from physics suggests that such a restriction would be unwarranted, that it's perfectly possible that the strong force or the weak force have had a different value, and so we want to know, why is it that it has the value it does? It didn't have to have this. And so that sort of restriction would be ad hoc and unjustified.
Sorry, just a quick follow-up. I think the thought was supposed to be, you're already restricting it to the nomologically possible worlds. So if you're restricting it, why can't, the objector also restrict it? Just restrict it more. That was kind of the thought.
Well, I guess I would say that such a restriction results in a triviality. It would just, all that would show is that relative to the values of the constants and quantities, the universe must be life-permitting, and that's trivial. That just is what fine-tuning means. So that would just, such a restriction would be trivial, it seems to me. It's sort of like saying a hypothesis relative to itself has a probability of 1. Right, so what? That doesn't seem to address the difficulty. Yes, let's take Kevin down here in the front.
This is more just clarification on the literature that's being talked about with this argument.
Yes.
How many physicists or cosmologists would actually hold this theory that the universe is, it's necessary that the constants and quantities have the values that they do?
Hardly anybody. I think somebody like Stenger would want to take this view, but he's clearly born out of a naturalistic prejudice. But superstring theory in particular hasn't delivered on its promises. I think a good number of physicists now are very disappointed in this research project. And in any case, even if this were the correct theory of everything, as I say, what it predicts is not a unique set of values, but this enormous range of values that are possible. So there would be scarcely anybody, I think, who would be so audacious as to say, I affirm that the values of the constants and quantities are physically necessary. At most, they would put this forward as a bare possibility. Maybe this is a possibility. By far and away, the alternative chosen will be the second one, that this is chance. It's simply lucky for us that the values all fell into this life-permitting range. Drew.
Actually, following up on the first question, I was just going to point out from a scientist's point of view, there's a fundamental difference between forces and constants to begin with. It makes sense to restrict the actual laws of the universe, to say that gravity has to be an inverse square law, for example. But the constant is simply a part of that law.
Yes.
That's a random number. So it makes, to me as a scientist, physical sense to say we can only deal with universes that have our same laws or they have the same forms, but where constants really could be anything they want to be.
Yeah.
So
I like the way of putting that, because if you plug in the values to those laws, then you really are asking what's the probability of the universe relative to itself, because then you've just given a description of the laws with the values it has. All right, any other comment on this first alternative about physical necessity? All right, well, that then takes us to the second alternative. Could the fine-tuning of the universe be due to chance? And we will reserve that alternative for our next class meeting together. So, because it would take too long to do in 5 minutes. So what we'll do now is end with a benediction, and then we'll enjoy our meal together. So let's pray. And now may the God and Father of our Lord Jesus Christ, who has at this time of year sent his Son into the world to be our Savior, fill our hearts with joy and gratitude for his inexpressible gift, the Lord Jesus, through whom we have redemption from our sins, new life in the Spirit, and the hope of life eternal. Amen.